Thanks for coming, all of you. I see some familiar faces from the last time. Thanks for coming again. And I see a lot of new faces also. Welcome all to East Bay Cloud Native. This is our second meetup only, and we plan on having many more. We plan to meet every third Thursday of the month. And please do suggest topics that you would like to listen on, because right now we are just picking topics based on we think what you guys might be interested in. But we would definitely like to hear what you are interested in and pick speakers on those topics. I would like to run through some logistics. In case of an emergency, we'll all exit from that door and out to the parking lot. And if you guys need any Wi-Fi access, the details are over there. And there are some on this board also. For the restrooms, you can go out this door, and once you turn right, you will see a restroom sign over there. So you can just follow the sign. So we have two talks today. The first one is on eliminating backend latency for microservices, and it's by Roland Lee. He has come all the way from Palo Alto. I didn't know you were coming from that far. I really appreciate you coming this far. A little bit of background on Roland. He brings about over 20 years of product development experience in the application networking industry. And he started as a development engineer of networking products and moved to head up product management teams. He holds a BS in electrical at Cal Poly and an MBA from Columbia University. So please welcome Roland.
Thank you very much. All right, how much time do I have?
45 minutes to
45 minutes.
50 minutes.
That's plenty.
Yes, great.
That's more than enough. Well, good evening, everyone. Thanks for having me. I didn't know how bad 680 is. Boy, it's a lot of traffic, of course. But it's nice up here. So I hail in the peninsula area in Palo Alto. Thank you for having me. Today, I'm going to be talking about how to eliminate backend latency for microservices. If I can just get a show of hands, you all's background, how many of you are developers? Okay, how about DBA, like databases? Okay, back-end developers? Okay, all right, good, this is good feedback. How about networking? Anyone come from a networking background? Okay, probably about 25%. Good. Okay, so a little bit about myself. I just want to repeat. I come from an application networking background, and about 3 years ago, I joined Heimdall Data, and I co-founded this with a bunch of people that I worked with over the years. And it's been out for 3 years now. It's been powering some pretty large networks. And I'm going to give you an idea, not so much about my company as it is about the concept of a database proxy, and how that can help developers, especially backend engineers, speed up their development time, increase their application performance, and increase the reliability of their backend data source. And in this scenario, it's really about SQL databases. So we're at Oracle, so it's appropriate. So we're going to sort of narrow it down to, if you have a SQL database, you may want to consider the concept of a database proxy. What that does is that everyone needs to create a data access layer. That's another way of saying it. You have to create a data access layer that your application interfaces with your data source. In other words, your database. That takes a lot of development effort, okay? What I always counsel and tell developers is that you should focus on revenue generating features. You should not be focusing on how to make the application faster and more reliable. That's what a database proxy can help you do. That's what you do afterwards. Focus on revenue generating features. How do your features and your solutions are more unique? And how is that going to bring more money as opposed to reliability and performance? But they are tied together. So the agenda today, I'm just going to give an introduction to what a database proxy is, and then I will give a demo. It's as simple as that. So let's start at a high level here. Web scale challenges. As more users and there are more applications, it implies higher data volumes, more tables, more changes to schemas. But the third one is what I want to focus on, which a lot of developers typically don't have networking backgrounds, and such that they neglect the high latency, network latency. And that's going to be particularly exacerbated when you go into the cloud. And the idea is when you run applications in AWS or Azure, Oracle Cloud, we're beginning to think, because there's so many tools there, oh, security, networking, that's going to be all taken care of by the cloud. But what you find out is that not everything's taken care of, and you need to worry about security, you need to worry about latency, and this is the big one I want to focus on. As you begin to instantiate your database instances in the cloud and the application instances, it may be geographically dispersed. And if it's geographically dispersed, that creates more the increase of round trip times will increase latency, which affects application performance times. Does that make sense? I mean, what you want to do is try to put it all within an availability group. I got it. But as it grows, and let's just say the resources aren't there, it's going to get it from somewhere else. And it may be hundreds, if not thousands of miles away. And so that distance between the application and the database could be very far, especially in the cloud. And we're going to talk about how you can mitigate those things. Any questions there? I want this to be very discussion oriented. Doesn't have to be, I don't want to be the only one talking. You can agree, you can disagree. This is a learning environment here. So we're going to focus on the latency on the back end. The other statistic I want to give you, and this came from Akamai. There's a lot of companies, a lot of startups that focus on the last mile. In terms of a mobile application, we want to optimize the application. We're going to focus on the last mile. A lot of solutions now that have been there, done that, have focused on the middle mile. Could someone tell me what I mean by the middle mile, or what are some solutions that optimize the middle mile? What do I mean by the middle mile, and what solutions are out there that optimize the middle? Pardon me? Akamai. CDN. There you go. You got it. So typically, CDNs cache static data here, content here, and they're optimizing. And Akamai will attest to this. That represents 30% of the overall network latency. And the majority of companies are focused on optimizing the last mile, but that represents only 10% of the overall network latency. If you do the math, it's really the first mile, where the application and the database is, that represents the overall, the majority of the latency. And that's really the content latency, or what we'd say the dynamic content. That's 60% of the overall latency that's causing the bottleneck of the mobile application. And as you know, mobile apps are huge now, and as they provide curated data, all this AI and information of providing recommendations for you personally, that all goes back to the database to get your personal information. So you're grabbing information from the database, and that chattiness, that round trip time, kills you. And that's why it's 60% of the overall latency. And it's a little known secret that people don't focus on, and where, as backend developers, you should also focus on as well. Okay, 60%. So one of the ways you can solve this is they're out there in the market today is the idea of a database proxy. What it's doing is it provides a lot of performance enhancements and reliability so that the backend developer doesn't have to do. Okay, and some of the vendors out there today are MariaDB has. Are you guys familiar with MariaDB? It's basically a derivative of MySQL. It's open source, and it's a drop-in proxy, database proxy that you put in between the application and the database. There's Proxy SQL. Anyone heard of Proxy SQL? It's quite popular amongst the MySQL community. It's also open source. And then there's a couple other ones that are more proprietary, and that's ScaleArc and then Heimdall Data. These are the four most well-known database proxies. And what they do is they offer automatic failover between databases. So if you have two replicate read databases, if it does health checking, and if it deems one to be unhealthy, it will automatically fail for the next. Okay, pretty simple. If you've dealt with Postgres, anyone deal with Postgres? Okay, it would be like a PG Pool 2 replacement. PG Pool 2 does connection pooling and failover. And then it also does SQL read-write splitting. Does anyone know what I mean by read-write splitting, that term? Anybody? Okay, so when you want to scale your database, you can scale it vertically by throwing more resources at it. So throwing more cores, throwing more hardware. That's scaling vertically. But that has only a certain amount of limitation. That has a limitation. The next thing you want to do is scale horizontally. And how do you do it horizontally? What's typically the general practice to scale a database? Sharding. And particularly, how do you shard? How does a database look? Tell me more. How do you sharding is one way, but how does the database look in terms of deployment in the back end? You would go right?
Yeah, I don't know, but I'm thinking of whether that means the same schema with different rows in each one, or whether that would be like some tables are here and some tables are there and some tables are in another.
So that would be like sharding. So you're correct.
So the last one?
So putting information in different instances, database instances. So what I was thinking, that's one way. The other way is yes, sir.
You have some read database and some write database that you cannot synchronize.
What do you call that? How would you describe that?
Read replicas.
Great. Read replicas. So what's typically done as well is you separate the write from the reads. Because writes are very heavy, reads are very cheap in the sense that it's not resource intensive. So all the writes will go into the write servers, and then you have a bunch of read replicas or read slaves, as they call it. And you throw all the reads to them, and then basically you can get a read back from them. Does that make sense? Read replicas. So what's the issue then? Because that's been around. Well, for a backend developer, whether it's sharding or separating or splitting reads and writes, that requires code changes. Okay? Every time you add a read replica or you add a write server, you need to modify the application to some degree. It could be very complex or sometimes it could be easy, but you would need to modify the application to say, hey, I just added another server, an instance. Okay? What the proxy does for you is that it's automatic. It's SQL aware. It'll know that, hey, this is a read query, and it will route the read query to the read replicas, and it'll load balance across the read replicas. And that's for a read, and for the write query, it will go to the write database. Does that make sense? You do it automatically, no code changes. So one of the benefits of a database proxy is it doesn't require code changes, generally speaking. You just drop it in, and a lot of these things are done for you. And then the other two is what I'm going to sort of focus on today, or this evening, in the sense that it eliminates the network latency in the back end, is caching. Most of these solutions can provide query caching. Last year, MySQL had deprecated their query caching. And I'll explain why that is, but the whole idea is to offload queries that are going to the database and also to increase application performance when you cache. That's by definition, right? It's offloading and making your application faster. And we'll talk about the implementation of that. Okay, so does that, yes sir?
One basic question, so where will this proxy reside? Next to my application server or next to the DB server?
Yes.
Where?
Yes, so both. So it depends on the product, and I'll describe it to you. The majority of these, logically speaking, is between the application and the database. All of these, or all of them do this, logically speaking. I'll answer that on how, for example, hybrid data can be different. We optimize SQL from an application perspective, so we're on the application side. So as you have every application, you just have a proxy that's in the application server. So it scales very nicely with the application. Does that make sense? So it's not on the DB side. Okay. Now, one of the beauties of, let's just say, Heimdall is that it's application code agnostic. And the reason why is, let's start with Oracle. Are you familiar with JDBC? Does anyone program in Java? Okay, so this was a clever idea from our CTO. We're just a JDBC driver. Okay, so if you're in a JVM, whether it's Scala, Go, or Java, what you do is you shim in our JDBC driver in between your application and your current JDBC driver. That's it. So it's a 5-minute install. All you do is you change the URL or class path, and you're done. Okay? So there's no code changes to the application. There's no changes to Oracle or whatever databases that you're using. It's a 5-minute installation. So it's very transparent. Yes?
So from this one, so your application code is not changing. So if I have code which is assuming transactional nature, asset guarantees, depending on, my code is depending on some of the asset guarantees, and I write, and I'm trying to read back, given the nature that it could get split across the read to a read replica, there is a possibility that I might not have the data yet written to the replica. So how is that handled?
So let me answer that with a question. How do you handle it today?
Today it's a transaction, right? So I have a single transaction and I'm writing it to the database and I'm getting it back.
Then you commit.
So I'm guaranteed that if I'm writing to an Oracle or a SQL on Postgres, it is somewhat restrictive in terms of my horizontal scalability, but I'm okay, but at least I get a consistent view of the data that I load to the database.
Right. So you're sacrificing performance for data integrity.
Correct.
Okay. So if it's transactional, it'll be transactional, and it'll be a pass-through for us. But I will answer that in the read-write splitting slide on if you wanted to scale out, but you also wanted to maintain the asset properties as well. Okay. So there's no changes to the application behavior. If it's transactional, it's transactional. But if you wanted, if it's a custom application and you wanted to optimize performance, we have the ability to provide that performance, and I'll show you. Okay. So this is one package. It's just a JDBC driver, and I think you guys see it's transparent. It's very easy to install, and you get the failover, the caching, visibility, and everything. We just see everything through the driver. Now, if someone says, well, I'm not a Java app, I'm not a JVM, well, then we offer a database proxy. And what that is it runs as an agent or as a sidecar process for those terminology for containers. It's a sidecar process. And proxy SQL, all of the proxies run this way. Okay? We're sort of special in that we have a JDBC driver. But this can be run in between the application and the database. For us, you can run it in the application server as well. It's just a sidecar process that speaks the database protocol. Any questions here? This is all about the packaging. Yes?
So we use Juke.
I am not.
Okay, it's a Java object-oriented query language. I don't know, that talks to the database through JDBC.
Yeah.
So I don't know if that will work with this new layer of JDBC.
So, question for you, what is your backend database?
Postgres.
Postgres, okay. So in that case, you can either use a Postgres proxy if you want, or you can use it as a JDBC driver, either way. So you're using JDBC today, which is the Postgres JDBC, right here, and you would just shim in the Heimdall driver in between. So it's just a jar file, so you can. So whether it's Juke, Python, Ruby, Scala, we don't care. As long as if it's JVM, you can use the JDBC driver. Okay.
Where do you install the agent? Is it in a database server or is
So it's similar to the other question. So you can install that agent anywhere you want. We recommend it to remove the network latency. Where do you want to install it? What? Why? Why in the application?
You're
You
going
have
down
caching,
round trip.
so caching will be local.
Correct. Caching local and you avoid the round trip. You always have a round trip, but you want the round trip to be as close as possible, right? So you would want to install that proxy in the application server, right? So all the queries that would have gone to the database doesn't even see, and it gets served out from the application instance really, really quickly. Okay. Did that answer your question?
Mm-hmm.
All right. So this is sort of a slide here. It's high-level data, but it can be any proxy that you want. What we're,
One question.
Yes.
Where the connection is the proxy going to manage the connection?
yes. Yeah. So I could have added, so all database proxies, proxy SQL, MaxScale, high-level data, we do connection pooling, we do the failover, we do the read-write splitting, and we do the caching. So all that's bundled together in the proxy. And if you choose to do the connection pooling by PHP has one, and other libraries, you can use those as well, you just turn it off. Okay. So as you can see here, these proxies are very powerful. And it could be, you get a one-stop shop for all these functions for the backend developer. Okay. Now, what's unique about here, I'm going to do a little bragging, is has anyone programmed or developed caching before? Can I show hands? There is a sort of a joke, but it's sort of very true. What are the two most difficult things in computer science?
Naming and invalidation cache.
Correct. Naming variables and cache validations. And those are still two very difficult problems. It's sort of tongue-in-cheek. Cache validations is a very difficult problem. And this is where our proxy stands out, is because we solve the invalidation problem as it relates to SQL. Logically speaking, we're in between the database and the application. But what we're doing is we are auto-caching and auto-invalidating SQL results. So as we see the SQL come through our JDBC driver or proxy, based on a bunch of algorithms, we're going to say we're going to cache those results. So the next time we see it, it's going to be served out from local cache. Okay? And it's automatically validated. So that whole cache subsystem logic, you don't even have to spend any time to develop that anymore. It gets offloaded into a proxy. And we found that, we did a survey, and we found that 20% of caching, developing a caching subsystem and maintaining it takes 20% of a developer's time. It's very complicated and it's very burdensome. That's 1 day out of the week, 20%. And a proxy could take care of it. Now here's what makes it unique. We're not in the middle, but we reside on each app server. So it's very nicely scaled one-to-one. For every app's instance, EC2 instance or Azure VM, you drop in a database proxy. And it will auto-cache locally, and then you choose the cache of your choice. So I want to be very clear here. For any database proxy that I showed in the grid, they're not selling you caching. What they're doing is they're providing the caching logic. And in our case, we're also providing the invalidation logic. You choose the grid cache of your choice, and we're going to provide the logic of which queries to cache and what to invalidate. So just to make sure we're on the same page, question to the audience. When I say you choose the cache, name some cache vendors out there. Pardon me? Coherence. Oracle Coherence. What else? Redis.
Is Hazelcast?
Hazelcast.
I was about to ask you about that.
Any others? Memcache. Give me some more. Have you heard of Gemfire? Pivotal Gemfire. Just want to name a few vendors out there. GridGain is another one, smaller shop. But those are all can be used as caches. Okay. So you choose the cache of your choice, whether it be commercial or open source, and the database proxy will cache into it as a key value pair. What is the key? Key is the query, and the value is the results that come out from it. Okay?
So it's not an inbuilt feature of the product.
Question?
It's not an inbuilt feature of the product.
The inbuilt feature is the caching logic. So what you need to choose is the storage of your choice. It may be in memory, inside the app instance, RAM, or it could be Redis, Coherence, or whatever you like. Okay?
But if we talk about the query, key is the query,
So the answer to that is it needs to be the exact query. The exact query. You need to
If
get
I
the
use name queries, then it should be because it would be parameterized.
Correct. Correct. And yeah, it needs to be the exact query we see. So we want to preserve data integrity.
And if there is a read, there is a select query, and there is an update query.
Yeah.
No, because the caching mechanism will be. But most of the Java tools, no one uses actual parameters in their query. Everything is a question of parameters. Everything is a parameterized.
Let's take it offline. Yeah. There's some things that we can do around that. That can be normalized. So, any questions about caching? There's a bunch of use cases I want to talk about what a proxy can do. So, let me give a few use cases. I talked about results caching. So we auto cache, auto invalidate, no code changes. And here's another one that might be interesting, is batch processing. This is what a proxy can do as well. The goal here is to reduce CPU overhead of commits. And the idea here is for single transactions, particularly for DML operations, there's a high overhead for the commits. So what's going to happen here is we're going to take these single DML operations, we're going to batch them together, put them on a single thread, and send them out as a single transaction. And what we found is that batch processing can really enhance the DML throughput, and we've seen performance up to 50 times, okay, just based on the batch processing. And I have a slide for that, but this is
batching the updates?
batching the inserts, the updates, and the deletes, by definition of the DML.
Oh, this is for the code which is not doing by itself on the application layer.
Correct. The proxy's doing it for you, transparently. Okay. So we're optimizing reads, now we're optimizing writes.
So that might lead into some application errors as well, right? Like if the developer had made some choices like I want these independent commits, and I'm expecting these independent commits happening. If the proxy has not committed to the database yet, and I'm reading something in between,
We lock it. That's not going to happen. It's not going to happen.
But
Because
How
they're
do you
drivers.
ensure the reliability of the data in that case? For
Let me get to the
example-
slide, and we'll get there.
Okay.
But good questions.
But just one question. You should have like at least a timeout on those batch processing because, like you said, so imagine if I do like I don't know 10 inserts on my database. Okay, the first one happens now, and the second one happens like I don't know 1 minute later. So this one will be stalled like 1 minute, waiting for the second one to create a batch. So we have like at least have a timeout. Say okay, if the second one didn't arrive so far, I just commit the first one. Otherwise, I stall the application file, right?
It's configurable. This time out. I answered it, right?
Yeah.
Okay. So the third one is we talked about better use of read replicas. And to answer your question about data integrity, what we have here, which is interesting in a proxy, is this idea of lag detection to guarantee fresh data. So if you have a write followed by a read, a quick one, a write and then read, there is a potential whereby the data has not been propagated to the read replicas, right? So what we do here is we have this lag detection window. If you do a quick read, then what we're going to do is if it falls within that window, instead of going to the read replica for the data, it'll go to the write server. Not the RIGHT, but the WRITE, the write server, instead of reading it from the read replica, because the data hasn't been propagated yet. Does that make sense? So there's lag detection. And if you don't use a proxy, you should develop that in anyway. I mean, that's what you guys would have to do. Right?
Can you repeat that again?
Okay. So if you do a write followed by a quick read, okay? So I write the data and I update, right? Then I want to read. When you do when the read is quick, it's going to go to the read replica because we're doing read-write splitting, right? But how about if the data hasn't been propagated, the write hasn't been propagated to the read replica? You're not reading fresh data. Okay? So the way we solve it is we have this. We've calculated a lag detection window. So when that read happens and it falls within that lag detection that we've calculated, we know that that data hasn't been propagated to the slaves yet. So we're going to go to the right server to get the data, to guarantee freshness.
What is the algorithm for the lag detection?
We calculate, it's a calculation.
I'll give you an example, right? Like, for example, if I'm updating my password, and then I'm trying to log in immediately, maybe there is a 1 second lag if I'm doing it manually, but if some bot is doing it, and it's going to be instantaneously trying to do that, update and reset the password, right? So that's, how do you detect the password reset for a single record in the database for the lag of a single record?
At a high level, because I don't want to get into the algorithms, but at a very high level, we detect, based on historicals, being able to know the time the replication happens from the write server to the read server. Okay, at a very high level, and it's pretty reliable.
So that goes to a original question somebody asked about the transaction. So are you suggesting we don't need to maintain a transaction in these cases if we have proxy in between?
I would say a couple things. It's really based on your application, so I don't want to generalize it, but I would say this, that it would, when you use a proxy, especially for caching, it would be helpful if you didn't have stored procedures, like use PLC, because we wouldn't be able to see it, and you couldn't. But we can still get around it. But if you want the auto caching, you don't want to be in transactions. You don't want to use PLC. It's a recommendation. It's a suggestion. Okay.
Are you going to be covering the auto invalidate? Because I have some questions on that. I don't know if you have a slide coming up.
Yeah, the slide's coming up. Great questions. Is this a good discussion? You want me to move faster? It's boring? Let me know.
So basically this lag detection logic pretty much solves the problem of any eventual consistent system, right?
Yeah. To some degree, in the sense of I'm going to give the example again, a write followed by a read. Okay? It's guaranteeing fresh data when you're doing a read.
Yeah.
Okay? Very simple. It's data integrity. It's data integrity. So, okay, and then failover, which developers typically don't get involved in. It's more NetOps, but that's in there as well. So it's a faster failover for MySQL and SQL Server. So SQL Server has always on. Does anyone use SQL Server at all, Microsoft? Okay, so you guys have always on. I don't know if you use it, but this just fails over faster. So it works in conjunction with always on. And then I mentioned PG pool. I think you used failover. This is just a PG pool replacement. This one would be the PG bouncer replacement, because it can also do read-write splitting as well. The issue with PG pool and PG bouncer is you just have to code to it. It takes development work. With the proxy, you don't have to do any development. It's all packaged for you. So let me put it all together on a slide here, and architecturally how it looks. In here, there's 3 application instances. So for every application instance, there is a database proxy. Okay, one-to-one. It's just a sidecar process, or it's a JDBC driver. Okay, and it's all being centrally managed by a central console. Okay, and you choose, if you want caching, then you choose the cache of your choice. It could be Hazelcast. If you're in AWS, it could be Elasticache. It could be Redis. And it's database agnostic, okay, which is great. So if you have a mixed environment, you can standardize on a database proxy and use whatever database that you want for performance or for whatever. Questions here? It's quite easy, just 2 components, a central console and a database proxy. So what if the central console were to go down? That's often asked. Well, we've separated the data plane from the control plane. So what ends up happening is that even though the rules engine in the brains gets cut off, the proxy will keep on going based on the rules that it had and how it was configured. Okay? So the data plane and the control plane are completely separate. Now let's get into caching here. I believe that was yes?
you have to configure each of the application server, like the, let's say agent, let's say if I want to configure each of, how do you propagate like those changes? Like, is it a master?
Yeah, the central console pushes out the configs. Okay? And you get full visibility, and I'll show you a demo. The analytics is actually very good. And I'll show you how it works. Okay, let's talk about caching. Let's go back there. Just to be really clear, because I think people get very confused about the caching. So this is sort of a blow up into the app server. It's really a two-tiered way of caching. It's going to cache the hot objects in local memory, and that's configurable. Okay? You'll be surprised in what we've experienced. Can someone take a guess, wild guess, of how big that local cache would be? What you have the size for it? Take a wild guess. Few gigabytes. Anyone else? Would I surprise you if I said it was 50 to 250 megabytes? It's a very small footprint. Okay. So if you have any experience with caching, the long tail's here, but hot objects, very small, very, very small. 50 to 250 megabytes. So people get concerned, oh, I have to buy this huge honking instance and have a RAM. No, you don't. You don't. So hot objects are there, and then for if you have a large data set, you can put the remaining in L2 cache here. So it's an L1, L2. Okay. What the L2 cache also serves as is not only to store a level 2 cache, but it's used as a mechanism for invalidation. So if you have more than one app server, this, whatever grid cache you use, is going to be used as a communication bus to invalidate the local caches. So when there is a write to the database, let's say application server 1, the proxy will communicate via the local cache to invalidate the other local caches, that table has been invalidated. That's how it's automatic. Make sense? It's invalidated, the cache is invalidated even before the write has even occurred on the database. Even before. Just to guarantee that there's data integrity. Now, maybe the cache effectiveness is not there, but at least it's invalidated even before the write occurs. Any questions on cache invalidation? It's all automated, and the SQL results caching is all automated. So, just to be clear, on a database proxy, it's very simple here. It's a two-tier look-aside SQL results cache. It's not a write-through cache. It's not a read-through cache. Okay? We're not writing SQL into it. It's a key-value pair whereby the query is the key and the value is the results. Okay? So there's no synchronization between the cache and the database. It's just a look-aside SQL results cache. Okay? It intelligently caches the results, and you auto-invalidate. And what it's doing is, again, back to the theme, is that we're trying to eliminate the latency here. If you can cache and present the data on the application side, then it doesn't have to go to the database, right? And so what you're doing is you're increasing application scale, you're increasing application response times all at once, and also increasing costs, right? There's less load on the database. Does that make sense? Okay. That's what you're doing on the back end to increase. So here's some metrics that we use. After we intercept the traffic, we will cache results only if there's a performance benefit, okay? So what I mean by that is that it just doesn't blindly look at a query and say, hey, that's been frequently asked, I'm gonna cache it. We're gonna look at a bunch of algorithms and say, hey, if there's network latency and it makes a lot more sense just going to the database and fetch the data, then we're gonna do that, okay? Let's keep on going. So what we're looking at here is we're doing real-time analysis, and we're looking at the query frequency and the variability. If there's a lot of writes and then reads, it's a combination, then it probably doesn't make a lot of sense to cache the results because it's constantly being changed. So we're just not going to cache it. That's part of the logic. The other one too, if you go to Redis, if our logic goes to Redis to fetch the data and there's a cache miss, then it has to go to the database, that's terrible. You've just doubled your latency, right? Does it make sense? You do a read to Redis, and then you have to go to the database to do the read. That's double time. So what we do is we prevent that. If we know that the data is not in your cache, then we'll go straight to the database for the data. So that saves in eliminating or reducing latency. I'm going to stop there for questions before I get into the demo. Any questions about the concept of a database proxy in terms of functionality, caching, failover, read-write splitting? Yes.
So what is the benefit of having a database proxy caching rather than just the front end, like data, like before the application, I just cache the data. Why do I have to go to the database, proxy database? What is the benefit of having the proxy database?
Okay, so what is the difference? So why cache on the front end versus caching on the back end? So we're talking about apples and oranges. So you're going to continue to cache at the entity level, the object level, which is non-SQL. So then you have to ask yourself the question, what is the behavior of the application? If it is accessing a database a lot, and it's very read-heavy traffic, which e-commerce traffic, if you're developing a web app, it's very read-heavy, then you're going to want to cache at the entity level, at the application object level, and you want to cache at the SQL level. Those are two caching use cases which are different. You're not doing one over the other. Now, what I have seen is because people don't know much about SQL caching, they try to have as little database access as possible, such that you cache at the front end. And that's another solution as well, whereby SQL caching isn't as much of a value, because you're caching already at the object level. Okay. Question? Yes.
Do you have any such use case where you talked about how that the proxy can either be on the application side or on the database side? Do you have any use cases where you would want both? I mean, if one's a sidecar, if you have a sidecar on the database side and the proxies in the application layer, is that any?
Okay, in our experience, we have found that. Let's see that slide. In our experience, you want the if it's for caching, it's just used for that use case. You want to present the data and service the data as close to the application as possible. So you would never. There's really no reason to have two caches. So just have the cache as close to the application as possible. And the whole point is not to have it on the database side because you're removing the latency. Because MySQL had query cache, and it was deprecated last year. And do you know why it was deprecated? It's no longer being supported. It doesn't work. In other words, it doesn't scale. It's caching here. It's caching. Not only is it manual, you have to choose which queries to cache. It's not automated, but that wasn't the concern. It just doesn't scale. Okay. This makes it very elegant in the scale. It's one-to-one. It scales as the application grows, and it's also very close to the application. So the whole idea here is proxies are optimizing SQL from an application perspective. And that's what you want to do. Think from an application perspective. Don't think from a DBA perspective. SQL, yeah, it's application oriented. Optimize it from an application perspective. Any other questions? Yeah.
So we use New Relic to manage pretty much to look into the transactions, database, service map, everything.
Yeah.
So if I have to monitor how this proxy is performing, that's a separate dashboard, I guess.
Yeah.
No, okay.
Yeah, so the question is, if you have New Relic, would this be a separate dashboard? So first of all, the proxies differ. I would have to brag and say our analytics are really good, but we're in no way trying to replace New Relic. New Relic, App Dynamics, those are great products. Those are part of the APM space, which is application performance monitoring. those are really good, but it's really not from only from a database perspective, from networking application. It's a very complete solution for application performance monitoring. Now, if you wanted just to focus on SQL analytics, we do have that. And I just wanted to give you an idea of what just our analytics, what we can do. So, you know, in music, there's this idea of like the top 10 music hits in music. So what we do is we can give you the top 10 queries to cache. So what you can do is we give you the queries, and then you can just click the button on the queries you want to cache. You can take some of our recommendations, you can take none of our recommendations, or you can take all of them. Now, last year, for the IT owner, not for the developer, but the IT owner says, you know, even choosing the queries, that's very cumbersome. You know, first of all, I don't know SQL very well. I just need to set it and forget it, okay? So what we did was, there's an aggressive knob where you do cache all. And most of our customers do that, whereby you don't even need to click them anymore. They rely on the database proxy to cache the queries that it thinks it needs to cache. So all of this in one button just caches everything. But what I wanted to show you here is in this application, it provides really good analytics on where the bottleneck is. Is the bottleneck at the database processing side? Is it on the application side? Or is it network side? So you're able to debug where the problem is. And in this case, the query response time for these two queries is 700 microseconds. So when we cached, in this example, it went down to around 70. So that's a 10 times latency improvement just by caching. So the blue button turns into gray. Okay. I think I talked about the use cases here about the read replicas. I don't think I need to go there. Lag detection. So has anyone developed and programmed lag detection in your application before? Anybody? For read-write splitting? Because if you haven't, you should think about that. If you don't use a proxy, so it's such that you get fresh data. Okay, so that concept I think is just very good for development practices. Okay, a write followed by read very quickly. Okay, let's talk about asynchronous batch process. This is a new one, and I'll try my best to explain to you. So I'm not a guru in this, but this is more the data analytics side or queries that are very transactional. So you have a data generator, and it's going to go through a proxy. So first you have a DML request, and what's going to happen here is that it's going to queue up the singleton transactions. And in this case, there's a batch size of 4, but the queue is 8 singleton transactions. And on the 8th transaction, once that queue is full, it's going to spoof the application and say, that's done. Done, it's taken care of. It's been committed, it's done. And in the background, we're going to batch it and then commit it as a single transaction. Now it does a few things for you. It lowers the CPU overhead of commits. So if you have a bunch of singleton transactions, what we found is those commits are very costly. So instead of having 8, let's say in this case, 4 commits, you're just having 1 commit as a single batch transaction. Secondly, it increases application response time. Once the singleton transactions are queued up, we're telling the application we're lying. We're just saying, done. We're taking care of it. Give me your next DML, okay? And in the background on a separate thread, we'll do the commit, okay? And this improves also DML scale. Does this make sense?
What if like the number 3 is like take a long time? Will it automatically detect like okay, this take a long time before it commits?
Well, when it's in this queue, we're in control of it. So there's no slowness here. Okay, it's going to fill up, and then it's very configurable. Timeout, also the batch size. In this case here, the batch size is 4. So once the 4 singleton transactions or requests are there, we'll wrap them up and then send them out as a single transaction.
What happens if I never reach the batch size?
You can have a timeout. That's configurable too. That's what we talked about, right?
roll back when it's timeout?
Pardon me?
Would it, let's say number
What
3.
happens first?
Pardon me?
What happens first, right? The timeout or the backslice?
That I don't know. Yeah. Let me get back to you on that.
So when you get timeout, will it roll back the number 5, 6, 7? Or
Yeah, so exceptions are logged, removed from the batch, and transactions restarted.
start?
Okay. So we found that this is a really good use case for data analytics. So that would be like Pivotal Greenplum, Amazon Redshift. You guys use any of those? This is for data warehousing. So you're getting large, huge data sets. We found that this type of batch processing can really improve the performance up to 50 times. So this is optimizing writes. Caching is optimizing reads.
So on that exception though, when you said optimize for analytics, I'm assuming that the point with analytics is maybe the exceptions are few and far between. Is that the idea there? Because when you lie to the caller and now you have an exception, what happens now?
It's logged. I mean, what's done is done, right?
Right.
And then we'll if there's an application error and exception, you're going to see it. Okay, you guys want to see a quick demo? Sure. Okay. How am I doing on time? 5 minutes? Okay. I don't want to steal the other person's thunder. Let's do a quick demo. All right, this is a picture of our dashboard, and I'm going to give a, has anyone heard of Odoo, which is a very popular app that has a backend, which is Postgres? We're running a load generator, and this is only for illustrative purposes. I'm going to turn off caching. I just turned off caching here. Now it's at 0, okay? And what I'm gonna do is I'm just gonna turn on caching. And this is how easy it is to cache. No more complex TTL or expiry for every query. You don't have to select which queries to cache. It's literally these 3 rules. I wanna log, I wanna cache everything with a TTL of 5 minutes. And then, you know what, I wanna have a query plan. Actually, I want to get your feedback. Do query plans matter to you as developers? No? Does anyone care about it? You do? Okay, because it gives me a feel for how detailed you are. And because some people just go wild. It's like, yeah, it's really important. But we can get that from Oracle. We can get that from MySQL. But wouldn't it be nice if you can also get it on one pane glass? So we can provide the query plan for you for every query. Okay. And I just turned on caching. That's it. Now it's going to cache every result that makes sense. And upon every write, add, insert, or delete, it is going to invalidate that cache. Okay. Now let's look at the dashboard now. So for this example, which is an e-commerce app, and I'm not exaggerating, the cache hit rate is close to 95%. So let's think about that. That means that only 5% of the queries is hitting Postgres now. 95% of the queries that would have gone to the database doesn't even see anymore. It's being served out from local memory. That's pretty cool. Okay? So increase applications response times, you're removing the network latency, the backend, for microservices or whatever you're running, right? And you're increasing database scalability. So that's one thing I wanted to show you. Got 5 minutes left here, and then I want to show you the analytics, which is really nice. What the analytics gives you is all the queries that are being cached. Here, you see every single query. And if I just click this button here, it blows up and gives you the whole query. And look at that. Gives you the execution plan. So it helps you drill down further of why is this stupid query causing the issue? It helps out in your logic as programmers. Is this helpful? So you got the query and you got the query plan, query extraction plan. We just get it from the database. So can you get this as developers? Of course, but then typically if it's a big organization, you have to ask your developer, then they ask you for your passport and your information, and why are you asking for it? There's a lot of bureaucracy. But now if you have everything here, it's really nice, okay? One more thing I want to show you on the analytics is the DB time here is 4.3 milliseconds. This is the round trip time, this is the latency. Now, a great way to debug this is like, hey, where's the latency here? Because if this number was huge, it was like 100, then what's going to happen is the DBA is going to say, it's your crappy code, fix it. And then you're going to look on your side and you're going to say, it's not mine, it's your schema. That's your problem. And for a large company, you see that a lot. You see people start pointing the fingers between the application group and the database group. So what you can do here is, this is product template. You can click on DB statistics. And it's going to give you the DB side overall response time, and that's 0.1 millisecond. Basically, it's 0. So what is that telling me here? I've got 4.3 on the app side, and I have 1 on the database side. Where's the latency? Pardon me? Network. Okay, that's where you can extrapolate. That's where you deduce. Application side was 1.3. We know that the database side isn't a problem. It's 0.1. It's fine. It's processing the query just fine. We know it's called latency issue. Then we can hone in on saying, how do we solve that issue? Possibly caching. Okay? Make sense? And with that, I think my time is up.
I have a question. You were going to talk about those substitution parameters, and you said the query is what the query string is the key, but it's got to somehow include the values of the parameters, right? I mean,
so the key, okay.
Because the result set has got to match with the input parameters.
Please forgive me. What I meant by let me be clear. For a key value store for the grid cache, the key is the query, and the value is the result itself, the SQL results. So when you see the query, when the query is the key, Redis or Hazelcast, whatever, will give you the results back. That's the value.
Right.
So you're not writing SQL into the grid cache.
Like if you go back to that picture with the queries on it, where the question marks are, I mean, if you're querying by, select from where user ID equals question mark, if you're calling it with the user ID of 1 versus user ID of 12, your result set is going to be different.
Yes.
So how can that be the cached in the cache, like that third row? That looks real simple. It's got 2 substitution parameters there.
Oh, where the question mark is a wildcard?
Yeah. It's not a wild card, it's a substitution.
Substitution, where it could be anything. And
right.
Then each.
You could say, like, call with name Smith versus name Jones.
Correct. Can I get back to you on it?
Sure.
Okay. I will get back to you on it. That's a good question.
I mean, you must do it, but
we do it, but
anything.
I just don't know. I just have to understand the implementation, because what I would say is that we have to cache the exact query. So people have asked, well, can't I make, if the results are the same, can't I actually make that a sort of a wild card where Jones Smith, it doesn't matter because I'm getting the same results? And we can't do that, because we want to make sure that the exact query, you get the exact results.
But I think that this screen is just a matter of security, right? Because if you
Security,
expose the
yeah.
parameters, like password, someone that's using this screen will just see like password for someone else. So, but like you said, this thing resides side by side on the JDBC. So on the JDBC level, you have the parameters. So you can cache the actual parameters, but it just show like as question marks by security reasons, right?
So yeah, maybe we were purposely obfuscating this. That could be a good reason.
Because otherwise, I mean, just select where password is blah blah blah, and then I can just see the password.
Let me confirm that, but I think you're right. Yeah, repurpose the obvious key. I hope you enjoyed this discussion. I hope you consider a database proxy. There's a lot out there. There's some that are open source, and try it out, and hopefully it'll help you in your application development. Thanks.
Thanks a lot, Roland. I've never used a database proxy before, so it's very good to learn this. I certainly will look into it for the next set of applications. Now we will have a second talk